Almost everyone is designing cavities in parts completely wrong. In this video, we're going to talk about why that is and the solutions to actually design them correctly in order to take full advantage of mass production 3D printing and get out of the old school way of cutting out these cavities and wasting a lot of time, effort, and material. So if you were producing a traditional part, generally what you have to do is you would get it molded, which means that you have to conform to the design parameters of that process, which generally requires that you cannot have thick features inside of the part. This ends up creating a situation where you want to remove material from the part. You would generally have like ribs or something inside of the piece, but you would cut out large sections of it because any thick monolithic part can't be molded because shrinkage would cause it to deform, or it just can't flow right and you create all kinds of weird surface deviations in how the part is actually made. So very often people end up going through and cutting out pieces like this, cutting out these large cavities. And while that's okay, it's not really an optimum way to make a part because it's an attempt to try to remove material, but in the context of mass production 3D printing, it can actually do the opposite and actually hurt the cost of the part. One of the first reasons is the fact that these additional cavities increase tool motion. So very often print times can increase if you are putting cavities into it. Since most printed parts are kind of like this, where the interior is a solid infill, kind of a composite part, and then the outer walls are where most of the material is. If you cut cavities into the part, then you're basically increasing the amount of material because you have these extra tool paths out here. Whereas if you eliminated them, you would just have the simple infill, which can be varied up and down to different levels of density so that you can actually have less material while still having an exceptional amount of structure on there, because you can almost have a person stand on this and you can't break it. And if we did a correct type of infill, like a triangle or something along those lines, then it would be as strong as a standard truss. So this old style of designing cavities is something that's left over that many 3D printing designers actually do because it seems like the process to do is to remove volume to remove material. But actually it's the opposite. What you want to do is you want to decrease surface area in order to minimize print time, cost, and volume. The other thing with this is that this actually increases complexity of the part and therefore increases failure rate. Because with these circles, you could potentially have stringing, you could have a deviation, you have the surface area where the outer nozzle is fully exposed, so if it has a slight misflow of some type, it's viewable inside of there. Whereas if anything goes wrong inside of this piece, since that part is solid from the outside and you can't see any sort of deviation inside of there, a cosmetic error does not cause the part to be a failure. So again, you want to minimize that surface finish in order to minimize rejection rate, minimize print time and material, and just make the part look a little bit better. Because ultimately, the right way to design this part would be like this. Because now you have a solid part that is arguably much more attractive than this, where you have a bunch of cutouts that look like they were added there to keep it alive. But again, you have all of that structure. And like in this case, since this piece has that internal structure inside of there, it's almost like a composite honeycomb, like a carbon fiber honeycomb, to where it has these outer wall flats that add a shear plate to the whole thing, and then the interior structure there, which gives all of the strength to it. So it's almost like an I-beam rather than just an engineered part there. That all being said, optimally, a 3D printed part would be fully solid. But there are times when you want to break that rule. There are situations where cavities can actually provide an advantage. If you have normal infill, then you have a consistent and isotropic kind of strength profile across here. Whatever the infill happens to be, it's going to be the same strength throughout. But what if you want to reinforce this, or you want to thicken up that infill and make it even stronger? Well, this is a situation when you can use cavities. By using cavities inside of this half arch here, we're actually able to increase the wall thicknesses of that lattice and make it very dense, because now it's fully solid as opposed to a solid outer wall and then the infill lines themselves. Putting in these cavities creates basically thick walls throughout, which means that we have an even stronger part than just standard infill, even though it's a lot heavier. But what you can also do with this is you can actually take these cavities and apply them to certain areas of a part. So now you can increase the strength of a very specific area. So like going back to the wing, you can put cavities across the leading edge of the wing so that it's exceptionally rigid right through there and much stronger without really adding that much more material. But ultimately, with these cavities, you still want to end up with a solid part because it looks better. So rather than cutting them out and leaving them viewable or cutting them all the way through, please don't cut them all the way through ever. Make sure there's always a shear plate on the back of it because it makes all of printing easier. Having through holes actually increases all kinds of problems with the first layer and so on and so forth. Please don't do it. But if you need to have cavities inside of the part where you're trying to change the strength of the piece, go ahead and still cover them over so that you can have these circles or whatever kind of leading edge issue is inside of there, but it's still inside the part and it still looks exactly the same from the outside. That way the cavities don't collect dust and dirt and bugs, and they don't create, again, manufacturing defects that could be visible because, again, they're increasing surface area, but allow them to be stringy. So like with this part, you can see right here we have all this fuzz because this is an interior feature and we wanted to induce this in order to make this point. But if this was fully enclosed and this was a cavity inside of there, like one of these circles, well, if we close off these circles, you'll never see that fuzz. You still have the same structural benefit, but it decreases post-processing and cleanup to get rid of those sorts of issues that could potentially arise. So cavities do have their place, but they're mainly for a structural component. Do not use them to remove material from a part. If you are trying to remove material from a part, just bias towards filling it in solid. Because again, you have the part basically filled with air, but you can also have the structure along with that air. So hopefully that covers where cavities are really useful. They are something that can be used, but most people really misuse them because there's an old ancient technology that is informing how people design for 3D printing, and it's really not helpful. Cavities are a bygone era when you can create a fully enclosed part, which has never really been possible before. You can put in internal cavities, you can place them where you want, you can modify how the part behaves in different areas so that you have this micro engineering capability to really control how the part behaves throughout the part without having to change materials or have complex assemblies or anything else. It's really a superpower of 3D printing because you can create these really complex geometries that were never possible before. Hopefully you can utilize it in any of your projects like airplane wings or anything else that might come along. And if you need a quote for your mass production 3D printing project, we will review the design when it comes through and tell you to delete all of those cavities. Have a great day, everybody.